Hello and welcome to today's algebra lesson. Today we are going to talk about equations of lines and what they can tell us about some characteristics of the line, specifically the slope and the y-intercept. So, lines can be written in a couple of forms. The equation of a line can be written as 3x plus 2y equals 5 would be one example, and we call that standard form, ax plus by equals a number. Or it can be written in what we call slope-intercept form, and actually this is the far more useful form. What you want to notice about slope-intercept form is the y is isolated. So if you're given a line in some other form and you want to put it in slope-intercept form, you want to rearrange the line so the y is alone. And once we have the line in this form, it'll be y equals some number, which is times x, and that number in front of the x will be the slope, plus some other number. M and B are numbers. Okay? B is the y-intercept, and we talked about intercepts in earlier lessons, and M is the slope. In this form, when you have y equals and everything on the other side, you have what we call slope-intercept form. And when we have our line in this form, we can easily find the slope and the y-intercept, and that is useful for a number of things. All right, so this is the form, and here's an example. Now the examples are written a little tight there. So look at this example right here. Y equals 0.968x minus 17.3. Right away, if I look at that equation that I've circled in red, I know the slope is 0.968, the number in front of the x. And the y-intercept, which we label with a b, is negative 17.3, because subtracting 17.3 is like adding a negative. So you see in this form, this is a plus. So if you have a subtraction, what you really have is a negative y-intercept. So let me erase that, and we'll go on to the next one. So when you have an equation in this form, right away you can pick out the slope and the y-intercept. And when we look at the next one, y equals 3 minus 5x. Now this one is tricky. This one is, the y is isolated, but it's not quite in slope-intercept form, but it's close enough. The number in front of the x. So this could be written as 3 plus a negative 5x. Because in our form up here, everything is written with pluses, so we write it that way to match the form. But what we see is m is the number in front of the x. It doesn't matter that the 3 is first. What matters is that the negative 5 is in front of the x. So your slope is a negative 5, and your y-intercept is a 3. Now, if I rewrite the equation in this form as addition, I can also rearrange it by the commutative property of addition to say that. And this is more classically what we call slope-intercept form. Okay, so the number in front of the x, the coefficient we call that of the x, is your slope. So once you have the equation so y is isolated, the number in front of the x is the slope. The number by itself is the y-intercept. All right. So this is showing you just exactly what I showed you in the last slide. Another example. Y equals 2 times x, or 2x we say, minus 7. The slope will be 2, and the y-intercept will be negative 7, because in our form, it's y equals some number times x plus some other number. When you subtract 7, it's the same as 2x plus a negative 7. Since our form says plus, whatever's after the addition is what our y-intercept is. In this case, it's a negative 7. All right, so this slide is a little busy. What if you have the equation of a line in standard form? You don't have it in y-intercept form already. Well, we learned how to do this when we solved literal equations. What you want to do, the object would be to get y by itself. So in 3x minus 5y equals 7, I want to get y by itself, because then I can right away tell what the slope and the y-intercept is. So the question was, give the slope and the y-intercept. It's very difficult to do in the form I'm given, so I'm going to rewrite. So essentially, this 3x minus 3x, you subtract 3x from both sides. So you 3x, and here's your subtracted 3x. These go to 0. And that leaves you with, but you have to also subtract 3x on the other side, which is what this is. We might have written it vertically, 3x minus 5y equals 7. And then you would have done minus 3x on this side, minus 3x on this side. And then you would have just been left with negative 5y. That's how we more classically did our work in class. But you don't have to do it that way. You can do it horizontally too, but they're doing the same thing. They're subtracting 3x here and subtracting 3x on this side. Let me erase some of this. So now, what I'm left with after I do that is this minus 5y, negative 5y equals negative 3x plus 7. I still haven't isolated the y. To isolate the y, I'm going to divide both sides by negative 5. Here, the negative 5 over negative 5 gives me a 1. And here, it's negative 3x divided by negative 5 plus 7 divided by negative 5. Each of these, don't forget to put the 7 over the 5 also. So what's done here is we get the 1y. Most of you are probably okay with that, but negative 3 divided by negative 5 is the same thing as a positive 3 divided by a positive 5. So that's where the negatives went there. Positive 7 divided by a negative 5. With fractions, if I have 7 over negative 5, that's the same as negative 7 over 5, which is the same as the negative of 7 divided by 5. So we've just written this 7 over negative 5 here as negative 7 over 5. When you divide both sides of the equation, you have to divide every term on the right, not just the first one. So that's where this 5 comes from. But now I have this in a form I can read. I can see the slope, do the slope in green, is 3/5, and the y-intercept is negative 7/5. Right there, and right there. So when you have the equation of the line, but you don't have it with the y isolated, or you don't have it in slope-intercept form, you isolate the y, and then you can tell the slope and the intercept. Here is another example of that. Find the slope and the y-intercept of the line 2x plus 3y equals 9. First, we have to get the equation in slope-intercept form, which means we want to get y by itself. In order to do that, what we did was we subtracted 2x from both sides. And this 2x minus 2x became a 0. So that left us with 3y equals negative 2x. So we subtracted 2x from here too, plus 9. Now I have 3y. I want y by itself. I have 3 y's. I want 1 y. I divide by 3, but if I divide that side by 3, I have to divide the right by 3 also. So now I get y equals negative 2x plus 9 on the top, divided by 3 on the bottom. The 3, negative 2x gets divided by 3, and the 9 gets divided by 3. So negative 2x over 3 is the same as writing, so negative 2x divided by 3 is the same as putting a negative sign out front and putting just the 2x over 3, a positive 2x over 3. That's where this is. And then 9 divided by 3 is 3. Now I can see my number in front of the x is negative 2/3. The number added on by itself is 3. The slope is negative 2/3. The y-intercept. So the slope, remember, we abbreviate that with an m. The y-intercept, we abbreviate that with a b. And that is in our y equals mx plus b form now. M is the slope, b is the y-intercept. Y equals mx plus b. M is negative 2/3, b is 3. All right, so here's another example. This one is a little simpler because the y is already isolated. I have slope-intercept form. Y equals 2/3 x plus 4. The coefficient of the x is my slope, 2/3, and the y-intercept is the 4. So those questions are easy. When you see those, don't try to make them harder than they are. If you're already in slope-intercept form, you know the slope is the number in front of the x, what we call the coefficient, and the intercept is the number at the end. Now this one, I have to find the slope and the y-intercept, but I'm not already in slope-intercept form. I have to get the y by itself. This one's actually a little easier than the ones we just did a couple slides ago. So I want to isolate the y. What I do is I subtract 7x from both sides. So what they didn't show you was they subtracted 7x from both sides, and that left them with a y on the left equals negative 7x plus 6. I have the y alone. I don't need to divide because it's just one y. I'm all done. So I can see the slope is the number in front of the x, which will be negative 7x. Oh, sorry, which will be negative 7. Do not tell me that the slope is negative 7x. The slope is only the negative 7. It is not the x. There are no variables in slopes of lines. And then the 6 is the y-intercept. Do not tell me slope is negative 7x. Slope is the number in front of the x. All right, and that brings us to the end of our lesson on Objective 1, is how to use the equation of a line to find the slope and the y-intercept. In the next recording, we'll take a look at Objective 2, which is how to graph lines once we have them in slope-intercept form.